Hey guys, it's John from THKP, and this is part 2 in our set series. In this part, we're going to talk about dealing out the cards. And this problem is a bit more complicated than it might seem because instead of just dealing out a bunch of random cards, we need to make sure we deal out 4 mutually exclusive sets. And what that means is basically just 4 sets of 3 cards where none of them overlap. So we need to write some algorithms to be able to do that. The first step is just to deal out a new deck. This one isn't too bad. We can just iterate over each of the 4 properties. And for every single combination of these 4 properties, we just add a card to our deck. And just so we have something a bit more interesting to look at, I'm going to go ahead and create a new deck and just kind of shuffle them out randomly and put them on the screen. We'll scroll past some of the stuff we did in part 1. If you haven't seen part 1, you should go check it out. Okay, so in our home, I'm not going to worry too much about, doing this the quote-unquote right way. I'm just going to sort of make it work. Call init state, and inside init state we'll create a list of rows. I'll just call this card grid. I don't know. It's a terrible name. So this card grid, I'll initialize it to a new list, and then I will create a new deck. You can go ahead and shuffle it. And then I'm just going to deal out 4 rows of cards. So each row will have 3 cards in it. So row, add, and I can just say remove last, dealing from the bottom here. And for each row, I just go ahead and add it to our card grid, add row, and this should be good. It should just deal out completely random cards once I do this. Now I need to display these cards. I can use this very similar code here, but I need to, instead of hard coding all this, I need to create this same exact structure programmatically. So this shouldn't be too bad. I'm just gonna create I'll call this column children. So we'll iterate through each of our rows in, what did I call it, card grid? And we'll just say, oh, and then this gets a little trickier because each of these rows has its own children. So we'll say widget row children equals blah. For each card in the row, I'm just going to add one of these, this expanded thing. So row children, add that. And then instead of this set card here, this hard-coded set card, we will use our card from our grid. Okay, and then at the end of figuring out the row children, we just add to our column children. And this is just going to be a row where the children is our row children. So then what we need to do is just, instead of passing in this hard-coded list, we'll just pass in our column children. Get rid of this, pass in column children. This is exploding because this init state hasn't had a chance to run. So let's run init state. I'll just restart the app. And here we have a bunch of random cards. You see this hazard thing down here because my layout is overflowing. We can put in a cheesy fix for that for now. Single child scroll view child. So this should just allow the screen to scroll instead of, exploding. All right, so that looks pretty good. And you'll see that if I restart the app, it'll deal out a new set of random cards. So it'll shuffle it every single time. Okay, the next step, once we've dealt out a deck of cards, so I'm just going to scroll back up to the top. So we've dealt out a deck of cards. Now we need some code to determine whether something actually is a set. We haven't written that yet. So what we'll do is we'll take a list of cards. Now, what does it mean to be a set? So firstly, there has to be 3 cards. So if cards length not equal 3, just return false. It's definitely not a set. Now next is for each attribute, the shape, the color, the count, and the texture, all of the attributes need to either be the same or all different. So for instance, let's just look at this green triangle, the green pill, and this red triangle. So all of the counts are the same, 1, 1, and 1. So that's valid so far. However, all of the colors are not the same. So red, green, green. So that automatically disqualifies it as a set. But also all the shapes are not the same. You know, triangle, triangle, pill, that disqualifies it. So let's look at just another example really quick. In fact, I don't see any valid sets on the screen right now, but let's talk about another invalid set that might initially look valid. So this green triangle, these 2 green squigglies, and these blue pills. So 1, 2, 3, that's valid because they're all different. Triangle, squiggly, pill, that's also valid because they're all different. But green, green, blue, not valid because there's 2 greens. So they would need to either all be green or, you know, all be different. This could be red, for instance. But then if you look at the texture, you know, outline, filled, and banded, that's also valid. So the thing that disqualifies this as a set is the colors. All right, so let's write the code that can actually do this. The way that I do it is I just create a set for each of the attributes of the cards. And we will iterate through all of our cards and put all of its attributes into these sets. Okay, and then as mentioned before, we just need to make sure that each of these sets is either of length 1 or of length 3. That looks pretty good. Now that we have this method to determine if something is a set, now it gets kind of tricky. So we want to write a method to get all sets given a list of cards. So if we have this big list of cards, say this is an entire deck of cards, we want to find every single set in that deck. So this method is going to be completely brute force. It's going to be recursive because we need to, you know, it's going to be the type of method where for every single card, we want to check to see which sets can be made out of that card. So we're going to be calling ourselves. It's a little complicated, but I'll try to move slowly and hopefully this will all make sense. So this argument will be all the cards that we're looking for sets in. We need a separate argument called the current set. Since this function is building a bunch of sets, this will be the current set that it's building. So you'll see that I'm going to call this function inside itself, and this, current set will be expanding as I am calling this function. We also need an index, and this index is where we're going to start in this list. So this function is going to be, once again, this function is going to be calling itself, and this index is going to be kind of incrementing along. So, as we've already looked at cards, we don't want to look at them again, so we're just going to be passing in the correct index. And And finally, I need a parameter that is the result of this function. So the result of this function is going to be every single set within this list of cards. So it's just going to be a list of lists. So what does the body of this method look like? We're going to be iterating over cards. We're going to start at our index that we passed in. So let's just say cards.length. And we want to look at the set that can be built out of the ith card. So as I mentioned before, we're going to be building sets up. So we passed in this current set. We want to build a new set, or a new potential set, I should say, out of the current set plus the card at I. So whatever current set we are currently building, plus this new card that we're looking at. Okay? So if the length of this potential set is 3, then what we'll do is we'll check if it's a set. If it is, we will add it to all sets. Now, if the length is not 3, this is where the magic of recursion kicks in. We can just call get all sets with our index, which the index is kind of the complicated part. So this is just going to be I plus 1. So we're already looking at the ith card. We don't want to look at that card again, and we don't want to look at any of the cards before it. So we're just saying I plus 1 here. We need to pass in the current set, which in our case is this potential set. So what this means is, you know, the size is not yet 3, meaning it's 1 or 2 or 0. Although it can't be 0 because we're adding a card here. But since the size is not yet 3, we pass it in here so that it can be built upon. So then we pass in all the rest of our cards, and then we pass in all the rest of our sets. Okay, cool. So this should be our get all sets function. And we can kind of test this. So if we go back down into our init state, so what we can do is shuffle our deck, and then let's create a list of set cards. And we can call our function get all sets. We'll start at index 0. The current set in the initial call is just going to be empty. And this is going to be deck. And then we'll pass in all sets. So now all sets is going to contain every possible set. So what we can do here is just say, instead of deck remove last, we can just say all sets row and C. So each set has a size of 3, so this should be valid. Oh wow, this is a funny issue. So I have a thing called row, and also my for loop parameter is called row. It's kind of silly. I'm just going to change this to be called y. Okay, so now if I init state again, what we should see is 4 sets. So let's do that. All right, and this actually looks pretty good. So this is a set because all the colors are different, all the textures are different, all the shapes are different, and all the counts are different. This is a set because all the counts are the same, the colors are the same, the textures are different, and the shapes are the same. Once again, same count, different shapes, different textures, different colors, and yeah, same color, different counts, different textures, same shape. So these are all valid sets. Looks pretty good. So we have a little confidence that that function is behaving correctly. We just need 2 more functions. The first one is to check whether or not sets are overlapping. And the way that we will check if sets are overlapping is we'll pass in some sets, and these sets are known to not overlap. So there's no overlap amongst these sets. And then we'll kind of pass in like a candidate set. So this is a set, you know, it's already been validated that it is a set, but we don't know whether or not it overlaps with these. So the goal of this function is to check whether it overlaps. So following our theme of brute forcing everything, I'm just going to expand every card involved in all of these sets. Call this all cards. And then we can add our candidate set. So all that this means is this is just every card that's involved in all of these sets. Then what we can do is just get all possible sets, which is that method we just wrote. Now all we need to do is we need to make sure that possible sets is the length of this plus 1. And what this means is that of all of these cards, you can only build this many sets, which means that there's no overlap. It means that this set is, you know, entirely exclusive from the rest of these sets. And since I called this function do sets overlap, I need to not this value, because this would mean that there is no overlap. So I just need to return not. Okay, so this looks good, nice and brute force, and we're using the method that we just wrote. Now let's write the function to get non-overlapping sets, which is the goal of this whole entire video. Get non-overlapping sets. This is going to be very similar to our get all sets function with just a couple additional wrinkles. So we'll pass in a list of sets, and this will be our result, similar to what we did in our get all sets function. I'll just call it results just for fun. Again, similar to above, we'll pass in a current set. This is the set that the routine is building. We'll pass in a number of desired sets. This is how many sets will be in this result. And then we need to have our deck. So we'll just call this all cards. So luckily we've already written one of these recursive functions, and this is going to be somewhat similar to that function above. First we can do our exit condition. We can just say if sets length equals desired sets, return, and this is results length. Now let's just iterate over all of our cards. We can check to see if the set that we're building does not contain this card. If the set doesn't yet contain the card, then we can build a new candidate set or a potential set out of it. Now we just need to see if this actually is a set. So this is similar to the code above. We need to check its length is 3. If the length is 3, we need to check that it is a set. And if it is a set, we need to make sure it does not overlap with any of the existing sets. So we can use result here, because result will, you know, contain all of the sets that we care about. And then the new candidate set is our potential set. Oh, and then this is called results. All right, so yeah, if it is a set and it does not overlap, then we can safely add it to our results. All right, and then the last thing we need to do is if the size is not yet 3, we need to perform some recursion. So we just call get non-overlapping sets again. The current set is potential set. Desired sets is always the same. All cards is always the same, and results is always the same. So that looks pretty good. Let's see if this works. So instead of get all sets here, we can just call get non-overlapping sets. And what are our variables? So we have a a current set, that's going to be the empty list. Desired sets is 4. And all cards is our deck. And then all sets. We can change the name of this to be results just because, you know, it's not all sets. And this for loop should actually work just fine as well. So what this should give us is 4 sets that do not overlap, and it will be different from this. We can see that these sets overlap because these top 3 sets all have this like banded diamond thing. So this would be an invalid situation. Firstly, it doesn't make sense to have the same card dealt out 3 separate times, but it's also these sets all overlap, so this would not work for the game. So let's run this again and make sure we have some non-overlapping sets. Okay, so firstly, this looks good because all the cards are different. It's not dealing the same exact card out. And next, we can, this is really hard to verify, but we can kind of tell that none of these overlap. So if you look at the things that look like they might overlap, like, you know, pill, 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 for instance, you know, these don't overlap because of the colors. Squiggly, pill, diamond, these don't overlap because of the textures. So this looks right. This looks like we have 4 non-overlapping sets. And the last thing that I want to do, just to close this off, is kind of randomize this because it doesn't make sense if they're all just on these rows. That would make the game trivial. So we need to take these 12 cards, shuffle them, and then deal them out. So all we need to do there is just take these results, say list. We'll create a list out of all of these results. So I'll just call this cards. And expand this to list. We'll shuffle this. And then instead of dealing directly from results, I'm just going to deal from cards. I'll say cards, remove last. All right, so this should take our results, shuffle them, and then deal them out. See what happens. Okay, this looks good. So yeah, this is starting to shape up. I'm seeing a set right. Oh, I thought I saw a set here, but this actually is not a set. Let's see, can we find a set? So there should be 4 separate sets in here. I'm not actually finding any. Maybe if you're watching the video, you can find the sets and let me know where they are. But yeah, I think this about wraps up the video. So we're dealing out our non-overlapping sets. In the next video, we'll cover all of the animations. We're going to add a timer, and we'll turn this into an actual game. So I hope you stay tuned for that one. And if you enjoy these, please like and subscribe. It helps our channel. And I will see you in the next one. Bye-bye.